22. Angus, read it out for me.
Find the vector of length 3 units.
Yep.
Which is perpendicular to negative 1, 4.
Okay, it's an interesting question, right? Because there's so many like different aspects to it. There's like, okay, we want to find this length, a vector of length 3 units. Then we have to also find something that's perpendicular to this, right? So we kind of need to be thinking about a few different things as well of how to actually get there. The first thing to think about is, okay, if this is negative 1, 4 over here, right? Where would we expect the vectors perpendicular to that to be? Over here, right? 90 degrees. Bang, somewhere there. Right? Well, here's the question, right? It just says find a vector. So potentially there's two possible answers here, right? Because remember, it doesn't matter as long as it has a 90-degree angle between them, the vectors are perpendicular. So here, in this situation, there's two possible answers. We could, but then the problem is we're not working with complex numbers. We'd flex. But then also the problem is that we need a particular length, right? So think about that for a moment, because what's the magnitude of this guy? This guy would be, if I want to find the let's say this is u, right? The magnitude of u is negative 1 squared plus 4 squared root 17, right? So we have this other problem. The other problem is that, well, at the moment, the length of this vector is not 3, so we have to kind of work with that as well. I think work with one problem at a time, right? The first thing to think about is, okay, if I was to find either of these coordinates, right, what vectors would they be? Essentially what you're saying is, right, remember, when do we know vectors are perpendicular? When the dot product is equal to 0, right? So if I have this situation where I've got u is equal to negative 1, 4, and if I want to find some vector v, which is perpendicular, right, what are these values that I'm looking for? That's kind of what I'm trying to think about here.
Well, wait, what did you say?
So, like, two problems we address, right? First of all, what's the possible vectors that would be perpendicular to negative 1, 4? And then how do we kind of change that vector so that it has length 3? Because obviously if we kind of took the same vector but just rotated it around, it would still have the same magnitude, just be root 17, right?
Yeah. To change the magnitude, you can, well, like, yeah, you want to find how to go from like root 17 to 3.
Yeah.
And the number that does that is 3 divided by root 17.
Okay, right, and this is kind of like this idea of going back to the unit vector, right? The unit vector is very powerful because it allows you to go back to something of length 1, and then you can multiply it by 3 to go to 3, right? So that's kind of the first thing. I'll write that out in a moment, okay? Before we do that though, what would x and y be?
You can just do like observation if it's 1 across and 4 up.
Yeah.
This perpendicular has to be like 4 across and 1 up.
Okay, right, so a kind of trick there is that we can, thinking about that observationally, I guess what you're doing is you're essentially seeing something which satisfies this equation. Negative 1x plus 4y is equal to 0, right? Because you're saying, okay, if I took the dot product of these, I want this to be equal to 0. And you're saying, what were you suggesting? What numbers again?
4 and 1.
4 and 1. So, yep, that works out. So one possible answer would be 4 and 1 here. And you can see that visually as well. 4, 1. Again, it's not the scale, right? That should be like there, probably more, right?
Yeah.
That's terrible. And what about the other one then?
Negative
-4.
4.
That looks a bit better.
Negative
-1.
Yeah.
-4. Like that. No, it's not better. Or -1, 4. Okay? And again, just checking that works. Hang on, -1, 4. -4. Okay, so good to check. Say it again.
Negative 4, negative
-4,
2.
-1. So -4, -1. Yep. And then they do get the product of 0. And so here's where we use what Matt said now, right? Because the idea is, like, again, these all have a magnitude of root 17. Okay, so not much we can do with that. But what we can do is we can say, well, why were we interested in what we called the unit vector last lesson? Because the idea is, if you can always go back to something of length 1, if I can like shrink this vector down, so I go, okay, well, a vector of length 1 would be like this, right? And then I can take that, and then I can multiply it by 3. That just gives me the result I'm looking for. I'm looking for a vector of length 3 units, right? So what we do is we say, okay, we have either 4, 1, or negative 4, negative 1. And then I guess the unit vector of each of those, yeah, that would be 1 on root 17 for 1, or 1 on root 17, negative 4, negative 1. And so if I want to find now something of length 3, then I can just take that and multiply it by 3, right? So we end up with 3 on root 17 for 1, or 3 on root 17, negative 4, negative 1. Yeah. So you can see like how this problem has a few different layers to it. You have to think about, okay, what are the actual coordinates if they're going to be perpendicular, and then what happens if I want to make this a vector of length 3 units.